Okay, I'm back and we're going to continue talking about geology. And so now we need to know, why is the inside of the earth hot? So the outside part of the earth, the atmosphere, is heated by the sun. So that's what's going to cause weather. But we're concerned about what's going to heat the inside of the earth. So the inside of the earth is hot from its original formation. And it's hot because there's radioactive elements inside that are constantly decaying and releasing heat. You don't need to worry about the gravitational heating. I would like for you to have a concept of what density is. So density is how compact an object is. So imagine that you've got a crumpled piece of newspaper that's this big, and then you crumple it more until it's this big. So the volume got smaller. The volume's in the bottom part of that formula, so that means its density increases. So in general, the more compact an object is, the more dense it's going to be. So just know the definition of density. You don't need to know the formula. But this is important because more dense things are going to sink in less dense things. So oil is less dense than water, so it floats on top of the oil. The more dense oil is underneath it. So more dense materials are underneath less dense materials. This is important because this is going to explain why the iron went to the center of the earth. It's going to be because of density. And it's also going to explain why clouds form, because clouds are going to be composed, or the air at the surface of the earth is going to be less dense because it's heated up and it expands, so it's less dense. So it's going to go up into the sky until it gets to the right temperature, and then it turns into a cloud. So this concept of density is very important. Okay, now how does heat move inside the earth? So you should know the definition of conduction, the definition of convection, and then the definition of radiation, and then where does it occur inside the earth. So conduction works the best in solids. So you would expect that the inner core of the earth would conduct, and also the mantle area, which is solid, would also conduct, and also the crust. But on the other hand, the outer core is liquid, so it's going to convect, and then also the mantle is going to convect as well. So the mantle both conducts and it convects. So what's causing the convection? Okay, it's going to be heat. So the heat from the interior of the earth is going to cause the rocks to expand, and then they're going to become less dense, and then they're going to go up to the surface just like a cloud. And so that's going to cause these convection cells, which in turn is going to push around the lithospheric plates on the surface of the earth. So the earth has layers because of density. So the less dense things went to the surface to make the crust, the more dense things went to the core to make the iron core. So you need to know the names core, mantle, and crust, and where they're located at, and what they're composed of. And then you should know that the core has two parts, the inner core, which is solid, and the outer core, which is liquid. And then it has the mesosphere, which I'm just going to call it the mantle. But inside the mesosphere, that's where you've got the convection. And then above that's the asthenosphere, the slippery part. And then above that is the lithosphere, the part that moves around, bumps into each other, makes the volcanoes, makes the mountains, and so forth. Okay, if I was to give you a map of the ocean floor, you should be able to point to it and show me where mid-ocean ridges would be located at. So you see those mid-ocean ridges are going down the middle of the Atlantic Ocean, and then there's some over, they kind of look like the seams of a baseball, and they wrap around. So you should be able to point to those. You should also be able to point to where trenches are located at. So go back and read your textbook and go back to my other videos and find out where the trenches would be located at. And then also you should be able to tell me where the Appalachian Mountains are and where the Rocky Mountains are in the North America. And the Himalayas. So be able to find all of those different places on a map. Okay, plate tectonics is the most important concept in geology. We're going to use that to explain a whole lot about geology. You don't need to worry about general relativity or the atom or the Big Bang Theory or DNA. So the Earth's lithospheric plates are broken up into about 12 plates, and these plates can be pulled apart. These plates can be pushed together, and then these plates can slide past each other. So on this map, I would like for you to be able to tell me where on the map are plates being pulled apart, where on the map are plates being pushed together, or sliding past each other, and then where on the map are plates being pushed together. So this would make for if I gave you the map, and then you could draw arrows to certain places on there and then tell me where this is occurring. So how do the plates interact? So the first one is the plates are pulled apart. So this is going to occur in the oceans at mid-ocean ridges. And then it also can occur under continents. So if it's in the middle of a mid-ocean ridge, as the plates are pulled apart, new material comes in, and it's going to form volcanic mountains in the middle of that ocean. And then as those mountains are pulled apart, new material comes in between, and then that solidifies and then breaks apart, and then new material comes up in between, and so that's how the continents move away from each other. A continent can be also broken apart if it's got one of these mid-ocean or mid-divergent zones underneath it. Okay, there are three different ways that plates can collide. So you have the ocean colliding with a continent, you have an ocean colliding with an ocean, and then you have a continent colliding with a continent. I want you to be able to draw pictures of those three, very simple pictures. So hold on. So for example, I would like for you to be able to, if it's an ocean hitting a continent, then you can make a ocean plate like that, and then a continent, it's going to hit this continental plate over here. But the ocean plate is going to go underneath the continental plate. So I'd like for you to illustrate that. And then as this plate melts, part of it's going to rise to the surface, and then you get volcanic mountains. So an example of this would be Mount St. Helens in Washington State. Also, you get a little bit of a trench right here where it's going underneath it, and then this thing here is called a subduction zone. Now, I'd like for you to be able to make a similar picture when an ocean collides with an ocean, and then also be able to tell me what kinds of structures, geological structures, would form as a result. And then the same thing for the continent hitting a continent. So tell me what geological structures form. Also be able to tell me where would you find an example of this on the Earth's surface? And then you got the transform. So this is where the plates are sliding past each other, and so it's going to break the plate, and then when they slip past each other, it's going to release a lot of energy in the form of an earthquake. Now you also get earthquakes with these other kinds of plate interactions. So don't get the idea it only happens with the transform. But an example of this would be the San Andreas Fault. You're not going to have to worry about interplate activity. So don't worry about this one. Okay, let's take a break, and when we come back, we're going to talk about magnetism.